We've so far discussed single-dimension arrays. Now we need to talk about multi-dimensional arrays. A spreadsheet, like in Excel, that is a two-dimensional array of rows and columns, or elements in a database. If you think about a single-dimension array is similar to a series of alphabet blocks set along in a row. They can be integers with numbers on them. They can be letters or a character array. So each of the blocks would have a single character on it, and then null at the end if it's going to be a string. They could be floats or doubles or any other native type that we have in the language, but there's just one string of them. That's a single dimension array, and we sequence through the array name with brackets at the end, 0 through whatever the length of the array happens to be. A two-dimension array, we already said, is like a spreadsheet, or can be thought of as a stack of rows of blocks. So you put another stack on top. Now, though, we have a multi-dimensional array, but they still all have to be characters, or all integers, all floats, all doubles. We cannot mix up the data types, even though there are two different rows of data, because what's really happening is that these items are one long contiguous group of bytes in memory. They are strung out one after the other in memory, and we just get to them by calculating the row sizes and adding the final element on the right-hand side, the least most value, to get the offset into the array, into the row. A three-dimensional array is similar to a Rubik's Cube. And I'm not going to go into all the dimension and all of that it takes to create a three-dimensional array, but it's going to be very similar to what you're about to see here in a two-dimensional array. Now here's a single dimension that we've already talked about. We have a little character array called hi. We've left this open so that it will be defined at compile time, and it will be 6 because there's 5 characters here and then our null, because we put the double quotes around it. So this is what comes up in memory, HELLO, and then the null at the end of it. So this is hi sub 0, hi sub 1, 2, 3, 4, and hi sub 5. And the sub goes right into there. That's a single dimension array. Now here's an example of a multi-dimension array and what you have to provide to be able to initialize it this way. This one we'll call greet, and we have an empty dimension here so that we'll let the compiler calculate that, but we don't rely on the compiler to calculate this value. We have to tell it how long the longest one will be, and then it will set it aside. If you skip that, it will give you an error that it needs a subscript in here because it's not going to go through these and figure out which one is the longest and set all this up for you. So here is greet 00 is this H, the very first byte of our array. And here's our hello, just like we had before. But these 3 bytes are padded out with nulls, because this thing has to be relatively square. We can't have these odd length values, because then if we did, we couldn't calculate our way through it with using the subscripts times the length of this value, of this length here, which is 8. Yes, which is 8. So we take 1 times 8 plus 0, and add that to the base pointer, and that gets us to this byte, which is the first character of Hola, sub 1 sub 0, HOLA, and then we pad it out with null so that the math for 2 times 8, 16, plus 0 gets us to this B, and bonjour, and 1 null. That's our longest value. And then ciao, we have 3 0, or 3 times 8. We can count off all those numbers, but that 24 added to greet will get us to the address of the C, and then we read until we hit a null, and that's a valid string. Three-dimensional arrays are set up just the same way. You just have another pair of brackets here, a more complicated initializer if you're going to initialize it. You can even have a four-dimensional array if you want. I wouldn't try to draw a picture of it. You could cause the room to implode, but two- and three-dimensional arrays are difficult enough to lay out in memory and in your program. But that's a multi-dimensional array, and it's very simple to subscript your way through it and find values in the array. You would use this for storing intermediate rows in a database. When you pull them in off of the database, you would pull them into an array. That's assuming that all of the values in the row are the same type. Now that's not likely in a database record, is it? That's when we're going to get into structures, and we'll see structures a few videos down the road here, but just whets your appetite a little bit here. So that's multidimensional arrays.